Hi, this is Adrian from Live to Learn Academy, and today we'll be doing lesson 1.6 in the Nelson Advanced Functions textbook labeled Piecewise Functions. So for those of you guys who are new to this channel, we drop videos like this where we go over the lessons directly from the textbook to help you along your advanced functions journey. Now, if you are somebody who needs tutoring, feel free to click the link in our description below. That way you can get in contact with our team, and our team will reach out to you to help you with any tutoring that you need. But without further ado, let's get into it. So piecewise functions, a lot of students that I've tutored in my life have always messed up with this concept, piecewise functions. And honestly, they mess up because they literally just get overwhelmed by the complexity of it. It really is a very simple lesson. So I want to just preface this lesson by just telling you guys that. But let's get into it. So what is piecewise function? What are they? Piecewise functions. You could think of it like this. It's a function with many pieces. Okay? That's one way to think of it. Another way we can think of it is it's a combination of multiple functions. Okay? So a function with many pieces or a combination of multiple functions. Now, the way people mess this up is they don't really understand the notation of piecewise functions. So this is something I want to spend some time on right now. So usually what they'll say is they'll say f at x, this is just an example from the textbook, is x squared when x is less than 2, and it's 2x plus 3 when x is greater than or equal to 2. Okay, so first we got to actually understand how to read the math. We got to be able to read this notation. What is this notation actually saying to us? It's saying that when we have a function, okay, I'm just going to do a quick graph. When we have a function, and this is 2 on the x-axis, when we're on the left of 2, the function is going to look like x squared. So think about the function x squared. It looks like this, right? It's a parabola all the way up to here. So on the left of 2, so everything to the left of 2, the function looks like a parabola. But everything greater than 2, greater than or equal to 2, so the right of 2, looks like this function, 2x plus 3. So 2x plus 3, it'll actually look like this. Okay? So this right here is y equals 2x plus 3, and this right here is y equals x squared. So all it's basically saying is to the left of 2, it looks like this function. To the right or equal to 2, it looks like this function. Now something I want to really, emphasize over here. Anytime you have a less than sign, it means you have an open circle. So if you look over here, this is going to be an open circle right here because it's just less than. But anytime it has a greater than or less than or equal to sign, where so the equal is also there, it will be a closed circle. Okay? So it's a closed circle. So this is an example of a piecewise function. This graph right here, it's a parabola on the left of 2, and it's a linear function on the right side of 2. So we need to know how to read that notation, and that's why I was really saying, oh, what is an open circle? What is a closed circle? What does less than of 2 equal? What does right side of 2 mean? All of these things are a part of the notation. Now, the reason we want to observe the notation is because piecewise functions can either be continuous functions or they can be discontinuous functions. Okay, so piecewise functions can either be continuous or discontinuous. Now, we have to know what makes it continuous and what makes it discontinuous. If you look at this graph right now, I guess the question you got to ask yourself is this function continuous or discontinuous? Obviously, we can tell it's discontinuous because there's a hole and there's this gap. And the gap is what's making it discontinuous. So what if we didn't have the graph? How would we know if a function is continuous or discontinuous? So this is an important question we got to ask ourselves. Is the function continuous or discontinuous? So let's look at this. Let's look at this example. Well, example 1. So the function says one if x is less than -1, x plus 2 if the function is between -1 and 3, and 5 if the function is greater than 3. So what does this say? So let's look at it in plain English. When it's less than 1, when it's less than -1, so meaning to the left of -1, the function is going to look like 1, which is just a straight line. It's just a horizontal line. But when the function is between -1 and 3, it looks like x plus 2. And when the function is greater than 3, so to the right of 3, it looks like y equals 5. So what we need to know with this function is that there are certain points that we need to test to see if it's continuous or not. And I like to call these bridge points. And the bridge points are literally found in this notation. So if you look at this, a key point here is -1, because on one side of -1, it looks like the function y equals 1, but on the other side, it looks like x plus 2. So -1 serves as a bridge point for those two functions. Now, the way we test this bridge point is we actually have to take this number, -1, and we got to plug it in to these equations to see if we get the same answer. So obviously, for this first equation, I can't really plug -1 into 1 because it's just a number. So for the first equation, we're just going to leave it as 1. But for the second equation, if I say -1 plus 2, it equals 1 because I plugged in -1 into here. Now what we notice is that when we do that, what happens? On the left side of -1, it equals 1, and on the right side, it also equals 1. So what does that mean? Because they're the same, they are continuous across this bridge. Okay, so let's bring it back. The first thing you got to know is a piecewise function contains multiple pieces. You have a piece, and another piece. The second thing you need to know is that piecewise functions are displayed in this notation. The third thing we need to know is what does this notation actually mean and where are the bridge points? This is really important. If we don't find the bridge points, then we're not going to be able to test where the function is continuous or where it's not continuous. And the fourth thing is we actually got to test the bridge points to see if it is continuous or not. So moving forward, we know that -1 is a bridge point. 3 as well is a bridge point because there's action happening before the 3 and there's action happening after the 3. So in this case, we would actually plug that in. So obviously for the first one, we plug in 3, we'll get 3 plus 2 equals 5. And for the second one, we know it's just 5 because I plugged it into here and I plugged it into here. So based off that, what can I say about these? The exact same thing. This is also continuous across this bridge. And mind you, this bridge is the -1 bridge, and this bridge is the 3 bridge. So knowing how to find out your bridge points are really, really important because once you test because you're going to be testing the functions across the bridge. Once you test the functions, if you get the same number, so same number, that means that you're continuous. Different number, different number means you're discontinuous. And it's really that simple. You are consistently testing whether the function is continuous or discontinuous across a certain point. Okay, cool. Let's look at another example. Now this is a thinking problem. So this is one thing that I like to put this one here because I see this on a lot of different test questions. This is a thinking problem. It tells us the function is x squared minus k when x is less than -1. And then it says 2x minus 1 where x is greater than or equal to 1. Sorry, -1. So obviously we know that -1 is the bridge point. But the function is saying what value of k makes the function continuous. So what value of k makes the function continuous? So what do I have to do? I actually have to take the bridge point, which is -1, and I'm going to plug that -1 into both of these guys. And if it's continuous, then the bridge points must equal the same amount. So if I say x squared minus k, and then I plug in that x squared, so -1 squared minus k, I end up with 1 minus k. And if I plug in -1 into the other guy, 2x minus 1, I'll get 2 times -1 minus 1, which is -2 minus 1, which is -3. So now I need these two to equal each other. 1 minus k must equal -3 for it to be continuous. And then I'm pretty much just solving for k. So 1 plus 3 is equal to k, 4 equals k. And that's my answer. So when you have a value of k equals 4 in this piecewise equation, that will allow the problem to be continuous. So I hope this video really helped clarify exactly how piecewise functions are. The main thing, guys, you have to know is how to read this. A lot of people see this and they just get really confused. It's not that confusing. There's a little things that you just have to know, but essentially it's just explaining the problem. It's telling you to the left of this number, to the left of this bridge point, it looks like this. To the right of this bridge point, it looks like this. That's all it's saying. And then you actually test the bridge points to see, is this function continuous or is it discontinuous? That's all you're doing. So if you found this video helpful, drop a thumbs up, like the video, subscribe to the channel for more videos like this. And once again, if you are somebody in Ontario and you need tutoring for advanced functions, feel free to click the link in our website, fill out the form, and we'd love to get in touch with you guys. Without further ado, I'll see you guys in the next video.